Okay, question 1 from the trial exam is from paper 1, 2018, the pure paper. We have a sector, OAB, with radius r. We're told that the angle AOB is theta. This is in radians. Okay, and we also know the area is 11 square centimeters. So we can recall the formula for the area of a sector when theta is in radians as this. So it's the area equals 1/2 r squared theta. Okay, and if it's 11 centimeters squared, we can set up an equation. Half r squared theta is equal to 11. To make that look a bit nicer, we can have r squared theta is equal to 22. So we have a nice result there. We might be using that shortly. We can't do anything as yet with that because we have 2 unknowns. So we need some more information. We're then told that the perimeter of the sector is 4 times the length of the arc. Now, the length of the arc is another fact we need to recall. The arc length AB in this situation, and if you don't know what I'm talking about, the arc length is this distance here. It has a really nice formula. It's simply going to be r theta. Okay. Now that means that if we know the arc length is r theta, we can compare the perimeter and set up an equation. So it also says here that the perimeter of the sector is 4 times the length of the arc. So we need to go for a walk around the shape to establish the perimeter. So if I start at O, I'm going to have r plus the arc length AB plus r again. Now I can write down the perimeter. So the perimeter is going to be r plus r theta plus r, another radius. If I simplify that, that's going to be 2r plus r theta. Okay. So far, so good. We now know that we can set up an equation with this perimeter and the arc length because the perimeter, 2r plus r theta, is 4 times the arc length. So 4 lots of r theta from earlier, which is here. Now you'll notice we can actually solve this for theta. We have r theta on the left, we have 4 r theta on the right. I can collect those together. So if I subtract r theta from both sides, I'm going to get 2r is equal to 3r theta. Okay, now if we assume that r is non-zero, which it will be because otherwise the sector would just be a point in space, dividing 3 by r, we will get 2 is equal to 3 theta. I'm just going to write that again. And dividing by 3, so we get theta is equal to 2/3. Great. So we can now substitute theta equals 2/3 into our equation up here. So let's do that. So theta is equal to 2/3. So we have that r squared multiplied by 2/3 must equal 22. Okay, just make r squared the subject. So we're going to have 66 over 2. So we have r squared is equal to 33. So we have r is equal to the positive root of 33 centimeters because we're talking about distance, of course. So there we've done it. Now, just regards to marks, you will get credit for recalling the basic facts about area. So you get a B1 for that because that's a knowledge recall. You will also get a B1 for using the information in the question and the arc length formula. You'll then get method mark for going through all this process down here. So that will be an M1, and then you'll finally get an accuracy mark for root 33. So that's out of 4 marks. Should take you approximately 5 minutes.